Thank you so much for the nice introduction. And to my audience, good afternoon, I guess, for most of you. For me, it's already evening since I'm broadcasting live from my hometown, which is in Belgium, Europe. But it's only 8 o'clock for me, so perfectly fine. I would say welcome to another Scale Me Up Expert Talk, where I'm going to walk you through the complex but nevertheless exciting world about running containers on the Azure platform. And you'll find out throughout the session that there's quite a lot to cover, but feel free to ask any questions. I'll be checking the chat box every now and then. And obviously, we also do have some time for Q&A all the way at the end. Now, what makes this an exciting session is because containers are popular, but also pretty hard to use. Now, before diving into technical topics, let me share a little bit about myself. So as you can see, I'm working for Microsoft and actually pretty new as a FT within the Azure Technical Trainer team within Microsoft. What we do is providing Azure readiness to larger customers and partners who are or using the platform already, but needing additional skilling, or customers that are totally new to cloud, but somehow or really want to scale up super fast. And my interaction with Scale Me Up is that before I joined Microsoft mid last year, I was a contracting trainer for Scale Me Up, and you still can find some content on the platform. So outside of these trainings and more like community webinars, if you want, that I'm still interested in doing. I'm trying to keep up and build up my network, stay in touch. So feel free to reach out if you got any questions on one of the other videos you find here on the platform out of my historical work for Scale Me Up. Before I joined Microsoft, so as you could already find out, I was pretty active in the Azure world already as a trainer, architect, and consultant. Was an Azure MVP for 5 years, but you have to give up that reward after joining Microsoft. And in the little bit of free time that I have, I still somehow walk back to the Azure platform, writing books, creating courseware, creating white papers. So I would say Azure is my playground for the last 6 years, almost full time. And containers is one of them. It's not really the core of the Azure platform, but it's one of the so many services that you can use and embracing, helping it. And that's the main objective of this session today. So zooming in on the different topics in the next 60 minutes. So I'm going to start with an introduction about containers. So what are containers and why should you use them? How they can help you in running your workloads. Next to that, a little bit on how to actually create a Docker container, like what are the building blocks and how you can use it with a quick demo out of Visual Studio, but it's not the only option you have. And then obviously from there, speeding it up a little bit and focusing on how to actually run your container on the Azure platform, ending with a more optimized way. So it's a little bit of like I would say the natural flow, starting from this is my application, I'm going to move it to containers after I convinced you why containers could be interesting for running your workload, and then slightly moving the container into an Azure working model, where we're going to start with a single standalone instance option and slightly moving to a more complex scenario. And again, Q&A is all the way at the end, so we should have about 10, 15 minutes all the way at the end, but don't hesitate firing off your questions already throughout the session. So with that, let's get started and jumping right into the technology, where the first part is a little bit high-level introduction about why containers, how they map with more traditional virtual machine workloads, and what are the core differences. So depending a bit on your interest or depending on your experience with containers already, it might be a recap, maybe a little refresh, or totally new, and that's all fine for me. Now, starting with this interesting way that organizations are working in today is a journey to the cloud. Now, this can be a private cloud, but obviously, since the core of the session is Azure, let's focus on public cloud. Now, when you look at the roadmap, it's not just a one-time shot migration. You have a lot of options. So you could start with your traditional on-prem infrastructure and moving to a cloud-based scenario by using virtual machine, lift and shift, running what you have as long as it's supported on Azure. You can keep running it inside virtual machines and not really changing a lot. And then all the way on the other side, you can step away from everything you've been running, developing, creating yourself, and using software as a service, like literally consuming an application like Office 365, DocuSign, OneDrive could be easy examples. Now, obviously, out of your organization, whether you're an ISV, maybe you're active in finance, insurance, manufacturing, doesn't really matter. You most probably are looking for something in between. So you're not going to move to the cloud and just running virtual machines, but you're also looking for something new that's not just ultimately moving to software as a service and just consuming it. And the middle section is literally what we call digital transformation or app modernization, where out of the journey to the cloud model, it's not developed by Microsoft, it's more like just the way the industry picks it up. One of the first waves we see is containerization. And again, that's a big reason why I'm talking about it. Now, the other important aspect is that although containers are really interesting, powerful, very interesting to run on a cloud-based platform, just keep in mind that it's not an end state. Because after containers, you could move to microservices, and some are already considering containers as microservices, but it depends a bit on how you architect your workloads within. And then ultimately shifting more and more to the right-hand side and running serverless, which in the Azure platform would be Azure Functions, could be Logic apps, so even moving towards codeless applications. But nothing on that, because again, today we focus on containers. Now, what is a container? It's somehow, I would say, almost identical to the concept of the virtual machine, but it's not a virtual machine. So what are the core differences? First of all, the footprint is a lot smaller. Why? Because there is no operating system. Now, it sounds a little bit like cloud magic if you want, but I hope it becomes a bit more clear later on when I'm doing some demos. But if you start from bottom up, you start with the physical data center. So you have a server in the virtual machine world. You're going to move to a host operating system running Windows, Linux, and on top of that, you install hypervisor, which could be the Microsoft Hyper-V, could also be VMware, maybe some other ones, but I'm pretty sure you're familiar with those. And on top of the hypervisor, you're going to run your virtual machine workload, installing a guest operating system, running again Windows, Linux, a lot of different flavors there, injecting the binaries, like if you run a Node application, if you run a .NET application, you need those binaries. And on top of that, you have your application and maybe the data if it's not running on an external storage component. Now, mapping that with containers, we're actually going to run the same application. So the workload itself is not really changing. So keeping it as an easy example, if you have a web application, you can run the web app inside the VM, where now you're going to run the exact same web app inside a container. So no real changes there. Now, where it becomes really interesting and why containers are interesting in like a cloud migration is because it's going to help you in a lift and shift scenario, picking up the application you already have and running in the exact same way if you've been running it for the last couple of years. And at the same time, if you want to move to a newer, like almost cloud native way of running or publishing applications, you can also do that. On the other side, although I'm talking about Azure, the world doesn't run on Azure anymore, or just Azure. And what I mean by that is that a lot of larger organizations are using a multi-cloud strategy. And that's another benefit where containers can really help you because there's no vendor lock-in. So container is relying on a standard. It's called Docker. It's a company and somehow a process, a methodology if you want. So as long as you have a platform that supports the Docker standard, then you can technically run your Dockerized containers, which means if you have your containerized application, what I'll show you in the next couple of minutes, how to build one. Once you have your Docker container available, you can run it in your on-prem development workstation, what I'm doing in my Windows 10 client. But you could also run it on a Windows server. You could run it on a Linux machine. You could move it on Azure in a couple of different services. But you could also run the exact same container in Amazon AWS. You could move it to Google Cloud. You could run it in an on-prem Azure Stack scenario, but you're never changing the characteristics of the container. So the cloud adoption, cloud embracement is also a lot easier because, again, it's easy to move around. And then moving to our Azure scenario, where, again, it's not just one single Azure container service, but out of the Azure platform, we have a lot of different Azure services already that now embrace, integrate with container workloads. So a couple of examples, and I'll obviously walk you through the details a lot more throughout the session. But you could start with probably one of the easiest ways is container instance. Now, what is a container instance? It's a standalone Azure service that allows you to bring in a Docker container in a couple of different ways and running that container as, that's where the name comes from, as a standalone instance environment. So easy said, you're going to bring your container into the Azure environment, and from there you're going to run it. Works fine, perfectly cool, but not good enough for some organizations, or not good enough for some workloads where we need more advanced management, more advanced control, like scalability. Maybe you look for better high availability, and that's where we have a few other services. Where another solution is application services. So what it means is that we have a service called Azure Web Apps that's typically used for hosting web applications like a .NET application, a Java Node.js application, where now instead of bringing your source code and running it as a web application in Azure, you can bring your container, again relying on the Docker standard, and instead of hosting source code, the app service is going to host your container, bringing in a lot of characteristics from Azure App Services, and now also supporting your Docker containers. And then probably one of the most common ones, or the popularst one, is Kubernetes Service, or AKS, where we provide you a Kubernetes cluster infrastructure as a service that's allowing you to have an end-to-end orchestration model. And then some outsiders, if you want, is Azure Service Fabric. It's a lot similar to the characteristics of a Kubernetes cluster with a lot of orchestration capabilities, high availability, scalability, but specifically initially developed as an internal Microsoft product that Microsoft internal was using for massive cloud scale, like the Bing search engine was running on it, the Hotmail was running on like the predecessor of Service Fabric. And now you could also use it for hosting your .NET applications, as well as running Windows-based containers. And then all the way at the right-hand side, we have a full partner ecosystem. So you could deploy a Docker Enterprise infrastructure, where you deploy the virtual machines, you run the Docker engine, and you're going to host your containers from there. We have an integration with Red Hat OpenShift. So it's a Red Hat virtual machine-based high available infrastructure in which you can host and run your containers. And a lot of other partners are also offering similar services. So in short, it starts with a single standalone container hosting model as a service. So just bring your container and we're going to run it, all the way to a high-end, high available clustered Kubernetes service or any of the other options we have. And the baseline for all of those are technically a library of Docker containers based on the Docker Hub, and I'll walk you through that scenario in the next couple of minutes in a demo, where you can literally reuse Docker containers from vendors, from maybe other community sources, and reusing them. And once you have it in a more private model, like running your internal in-house developed workload applications, maybe running those obviously not inside the Docker Hub, but you could move them into a container registry, a container repository if you want, and that's called Azure Container Registry. Now that's a quite long, detailed introduction, I hope. So in the meantime, you know, like what's the interesting part about using containers? Where do we come from? Next to that, we decided to run our containers in an Azure public cloud environment. So the next step is obviously like, where do we actually start? Like, we understand the concept, but how can we take it a little bit further? My first rule of engagement, if you want, is start with the basics, build up from there, and make it more complex, but only when you need to make it more complex. So what it means is, if you don't need the full orchestrator, then skip the full-blown orchestrator. If you have a standalone application, like what I'm using in my demos later on is e-commerce example, because everybody's pretty familiar with e-commerce as a web application, and it's a bit more fancy than just showing you a static web page with a hello world message on it. But if that's okay enough for running your application, because maybe you don't need the full high availability, maybe you don't need a lot of performance scalability, then that's perfectly fine. So, and that's partly I would say, the mindset of the Azure platform, that it's going to embrace the Docker standard, allowing you to run the containers. And it's really up to you to find out or to figure out what kind of Azure service that you're going to use best for hosting your Docker containers. And in the field, it could actually be all services in combination. I do have customers running a lot of Docker containers in Azure instance, like the standalone option. And I got even more customers using the full orchestration capabilities from Kubernetes, and also running that one for dev and test production. So a lot of options there. Now, what's the baseline? It all starts with running your container workload. Now, what is Docker? I mentioned it already a couple of times. Docker is an open sourced containerization platform. So there's a company, an organization who came up with the fabric, if you want, and the company, no surprise there, is called Docker. And they somehow, I would say, made it pretty popular, because they also made it pretty straightforward, pretty easy to not just build containers, but also running them. Outside of that, you already know it is natively supported on Azure in a lot of different services. And next to that, you can build Windows containers, and you could also build Linux containers. Where again, if you think back about one of my first slides where I mapped it with a virtual machine, you still have your binaries. So an easy example could be a Java app, where you know that the Java kernel, the Java framework can run on Windows and Linux, the same for Node. But for example, .NET Core can run on Windows and Linux, but the full-blown .NET itself can only run on a Windows platform, which means in container terms that you're going to build Windows containers for running your .NET application, and you might move to a Linux underlying infrastructure baseline for running .NET Core as well. So again, pretty flexible. So the starting point is running an operating system, and that operating system becomes your container host. So pretty similar to a physical machine on which you're going to run virtual machines, where now we have our operating system running Windows or Linux. Could be Windows client, could be Windows server, could also be a Linux alternative like Ubuntu or the Red Hat OpenShift I already briefly talked about. Now, the nice thing with the Windows platform is that it allows you to run Windows containers, pretty obvious, but it also allows you to run Linux containers. So that's a benefit as let's say if you're a developer and you're running a Windows client, like in my case, Windows 10, I can easily switch from running Windows containers to Linux containers. And actually throughout my demos, I'm only going to use Linux-based containers, although my host for now will be Windows. So actually pretty mind-blowing already. The little piece of magic in the back that allows you to run the containers on top of the Windows platform and switching from Windows-based ones to Linux-based ones is Hyper-V. So the starting point on Windows 10 client or Windows Server 16 or 19 is enabling the Hyper-V engine, but you don't have to install the full Hyper-V application, or enabling the containers feature, and that's specifically for a Windows Server edition that gives you the Windows Server operating system, including the container option. Once you have those running, all management is done from command line interface, where we're going to use the docker.exe. You could run it in a PowerShell, but it's not relying on PowerShell as such. You could also use it in your command prompt. And on top of that, and that's the open source part of it, is that the Docker desktop, your Docker engine, if you want, running on your host is totally free. Now, there is also a Docker Enterprise Edition, and that's like almost identical to running a full-blown orchestrator like Kubernetes, but then it's not coming from Google as the vendor, it's coming from Docker itself. So a couple of examples here, but screenshots are just screenshots, and I'll walk you through the first little demo. So I'm running Docker, it's this little whale icon down here. And if all goes fine, it's going to give me this little pop-up window. At least that's the expectation. It's thinking about it. Come on, help me a little bit. There we go. So what it tells me is I'm running the Docker desktop version. 2.3, not that important, just a versioning number. Every couple of weeks, there's a new edition coming out. But under the hood, it's supporting the Docker engine. That's really the intelligence, the kernel, if you want, that supports it. And that's version 19. It also supports Docker Compose, where Docker Compose is a technology that allows you to build a collection of containers, like a web frontend, a middleware, and a database backend. 3 standalone containers, but somehow all 3 together forming your workload. And then Kubernetes up here that allows you to run a Kubernetes test infrastructure where you're not going to run the full Kubernetes, but it's going to give you the full Kubernetes experience from your local development station. And obviously the versioning is important because every now and then all those engines, the Compose and Kubernetes, are getting new features where obviously it is important for you to follow them. Then a couple of easy comments to walk you through. So we have Docker, that's our little engine, and we're going to use Docker exe to integrate. So the first one that you should always run is Docker info, and that's what I did like a few minutes before starting the session and finding out that it was not running. Why not? Because it actually ran an update like 30 minutes ago. Next to that, it's going to give you some details about how many containers you have, how many of them are running, how many of them are stopped. And next to that, we have a Docker image command, and that's going to show me how many images I'm having. Now, what's the difference between an image and a container? An image is an offline, literally an offline image. And once you're going to run it, you're going to start it up. That's where we talk about a container. So a container is a running app. An image is the offline version of that. So if I run Docker images, you can see that I have a full list of images available. And think of an image as a pre-configured subset of an operating system, including the binaries, including the application. But the nice thing is that it's not having a full operating system inside the container isolated environment. So as you can see, I'm running a couple of them. So I do have my baseline container images for .NET for supporting my ASP applications. I'm using the .NET Core SDKs. I got a few other examples here. And what I also can do is running a new container. Now I showed you I'm using Windows, no surprises there, but it allows me to run a Docker client as well. So if I do Docker Ubuntu and a parameter IT, which is interactive, so it's going to show me something on screen, that's not immediately working. So I can do Docker run Ubuntu, and then a little bit of magic is happening. So it's telling me I am unable to find the image, but I'm going to pull it down for you. Now, obviously, the question is like, where does it come from? And that's where before I talked about the Docker Hub. So you can connect to hub.docker.com. You initially register, and that's where you can search for software containers. So I'm using Ubuntu. As you can see, it's available there. It's only been updated like 25 minutes ago, and it is an official image. So you got a couple of options here on the site. And if you want to use this container, you need to execute docker pull Ubuntu. Now, to save you some time, you could initially just execute docker run Ubuntu. And if Docker itself cannot find it on the local machine, it's just going to grab it from that public Docker Hub. So back here, I did docker run Ubuntu. It pulled it down, and that's about it. Now, technically, what it actually did is starting the container, running my Ubuntu as a stripped down operating system, virtual machine if you want, but it's not a virtual machine, but immediately closing as well. So that's another characteristic of a container. When the container itself is not having any instructions on what it needs to do, it's going to start up, it's waiting, and it's going to stop again. So I'm going to try the other one again, where this time I'm going to move it to an interactive mode. Since I already downloaded it, I pulled it to my local machine. It takes a split second and my container is running. So what I have right now is, since I provide an instruction like run the Docker Ubuntu container in an interactive mode, it's actually logging me in as a root user inside my Linux Ubuntu container. So from here, if you're familiar with a couple of Linux commands, I could do ls. It's going to provide me a directory, a list of all the folders. I could do top. That's the baseline Linux command for showing me the actual running processes. And you can see that it's almost like, again, a virtual machine. It's not exactly the same, but it allows me to run my container. I could exit it, and then I'm back at my prompt, where now if I open up a second window, I can use another command, and that's docker container list, and that's going to show me an overview of my active running containers. So this one is my Ubuntu container, and you can see I fired it up like about a minute ago. And inside the container, without telling it anything to do, it's actually recognizing to launch bash, which technically means open up the Ubuntu machine and show me the prompt, and that's literally what happened. From here, I could also do docker stop and pointing to df5b and so on. What that means is my unique container ID. So try to keep that in mind, df5b. It's gonna stop. I'm running docker run Ubuntu again. And all of a sudden what happens is down here, it's creating a new container. So my 5df and so on from the previous one, like the host name, if you want, of my container is now a new one. So I'm not starting the same container. I'm literally building up a new container, but based on the same image. So that's the baseline about using your Docker integration. Now the next step is running containers on Azure. Now before we can do that, we actually need to build our container. So obviously, depending what your container is doing, you might need to build one yourself out of, for example, Visual Studio or another development environment. Or if you use like a MySQL, Ubuntu, PHP, Nginx, like a pretty popular Linux-based proxy, reverse proxy, you can just grab that container image from the Docker Hub and you can get started. So my example is based on an e-commerce.NET Core example that I have in Visual Studio. I compiled it into a container. That's another command you can use. Docker build together with a set of parameters that's stored in a Docker file. And from there, it's going to create this little bubble. And from here, once we have our container image, it's been tested, validated, we're going to run it on Azure. Now, running it on Azure means that we need to have a repository like a landing page, if you want, where you're going to store your containers. And that's Azure Container Registry, or sticking to the alphabet soup, it is Azure Container Registry, so also known as ACR. So ACR allows you to store images. You can push them, you can pull them, and from there you're going to run them, hand them over to other actual container running services, which again could be VMs, could be container instance, what I'll show you, could be Azure WebApp for containers, and eventually ending up in a more formal, high available container cluster using Kubernetes. When you deploy ACR as a service, you need to come up with a versioning, like what kind of licensing flavor, if you want, consumption-based flavor do you want to use? Well, you have three different options, basic, standard, and premium, where I would say the premium is recommended because it's giving you a lot of storage capacity for container images. It's also giving you a lot of performance, and maybe even more important, that it allows you to replicate container images across different Azure regions. So if you have container workloads in different Azure regions, instead of building 5 or 10 or 50, if you want, different container registries in different Azure regions, you could build one of them and it's going to replicate and using a single namespace. Now within the container registry service, we have the registry itself recognized in the Azure CR.io namespace. Next, we have the repository, and that's where you're going to store your offline container images. You're going to push your containers into the registry, and from there you can start it up and running your application in, again, any of the running services. If you want to optimize it a little bit, and that typically means automation, you can also use a concept that's called Azure Container Registry Tasks. So it's going to allow you to, for example, pull new containers from your local client whenever there's an update, like a new build, recognizing it, using that as a trigger, and moving it to the container registry. Or expanding it to, again, multi-regions, detecting if a container is failing, that a container is down, automatically restarting. So that's like a little bit of automation. So what do we need for that is the container registry. So from the Azure portal, because it's a bit easier to demo, but you could also use PowerShell, Azure Command Line, maybe Azure templates if you use infrastructure as code. Container registry. Where it's going to ask you some basic Azure parameters. So it needs a subscription, a resource group, like where do you want me to store the resources, a unique registry name, a location somewhere in any of the Azure data centers, and eventually the SKU, like what are the characteristics of the registry. So from here, you provide those settings, you push the review button, and it's going to deploy it. Now, since I only have an hour to talk about all this stuff, I already deployed one for you. So once my container registry is deployed, it's just running as a service. That's where we can start using it. So my namespace, if you want, is the PDT simple ACR. I can run ACR tasks. I can get a view on my availability. I got 100 gigs in space, and for now I used like 380 of that, so plenty of space left. And even more important is integrating with security. So what those two vendors are doing, we're embracing them in our container registry service. So it's an additional cost on top of running the registry, but what it provides as a capability is that it's going to scan your containers or container images for vulnerabilities. So if you have like a legacy application framework, then the container registry by itself is not really doing anything with it. But if you add the additional security option, it's going to scan and alerting you like, oh, you're using an outdated .NET framework, or maybe you have a non-official Docker Hub image and you never know who created it, which also means that you don't really know what's running inside of it. And that's where the security tools are actually handy. So it's a little bit of like an anti-malware for container images. Now, what we need to do from here is back to our development station and pushing the container into that registry. So back to Docker images, where we have our pre-configured image already available. So what I did to speed up the demos a little bit is compiling my e-commerce example. So a .NET Core application running inside a container. And now I want to move this one to my cloud environment. Now, there's obviously quite a lot of security involved. So first of all, you need to have Azure admin permissions to deploy the ACR. But next to that, you also need to authenticate. And on top of that, your name of the container needs to reflect the name of the registry. So what you can do is using Docker tag, and that's going to add a label to your container image. And the outcome of that is technically the second line here. So I have my PD tender simple commerce. That's my source application, my e-commerce web frontend. And if you look at a container ID, the D3E44 and so on, that's the unique ID of my container. So next to that, I ran Docker tag, source name tag, target name, and that becomes the PDT simple ACR. That's the name of my container registry inside Azure, and I'm going to provide the same name for my container image. Where next we're going to use Docker push. And Docker push needs the name of the repository and the registry. So we're going to do Docker push and just copying this out. And it's trying to upload. So it starts with the different layers similar to the download of my Ubuntu example. So technically my container image is a collection of, 10, 12 different layers here. And it tells me I'm trying to, but I need authentication. What the authentication means is not my Azure admin credentials, but it needs access to my container registry. So that's the next layer of security. So what we can do here is running an Azure command called AZ from Azure command line, ACR and login. And next, it's going to ask me like, yeah, but what ACR do you want me to use? So I need to add some parameters, being the name of my registry and the resource group in Azure. If you would have multiple registries with the same name, then making sure that you're using the correct one. So it's AZ ACR login, like authenticate against the Azure Container Registry, where the name is PDT simple ACR, and the resource group, and I just need to sneak a little bit, simple C WebApp. So I'm telling my Docker command, like that is the container registry I want you to use. And if all goes fine, it's going to authenticate me. Now, how does it know out of my command prompt? How does it know my credentials? Because obviously I'm already pre-authenticated in Azure and it's using my token to do that. But it's still 3 levels of security if you want. So now it's pushing into the cloud. Again, to speed up the demo a little bit, I already pushed my container, but still doing it live. And it's obviously going fast because it's not changing anything. So I can close my local Docker. I don't need it anymore. And from here, I'm going to run it inside my repository. So my copied, my pushed container is the simple commerce that I have here. And it's in my registry. Where now we can move to the next step, and that's running the container. Where again, the first option is container instance. So again, what is container instance? It allows you to pick up a container image from the registry, but it's not exclusive to Azure Registry. It can use the public Docker Hub right away as well. Or if you have a private container registry or you use AWS Google Cloud Registry, then you could use that one as well. It provides you detailed logging of what's happening from the container instance perspective, like showing you the performance characteristics, how many CPU memory is the container live, and so on. And what I said at the beginning, it's literally allowing you to spin up a container, running it, stopping it when it's finished, or keeping it running indefinitely, almost like a full-blown virtual machine, but it's still running the container. So the next step is creating a container instance. Where it's again asking for some baseline information. So let's call this the ACI resource group. A name for my container, let's call this one Scale Me Up Live, and running it in Europe since that's where my registry is. So next, obviously, it needs a source. It could be an example out of Azure itself, Azure Container Registry, or another registry that I just talked about. So we go for Azure Container Registry. And again, since I do have admin permissions in my Azure subscription to use all this, I can just click around. Maybe you need some additional permissions to do that, but not going to make it more complicated. So it's asking for my registry, the name of my container. Out of the baseline of my container, it's Linux one because it's .NET Core, so perfectly fine. And next, it's asking me the sizing. So the default is 1 CPU and 1.5 gigs for running my web workload, but we could move this out to 16 cores and 8 cores and 16 gigs of RAM. If you want to run it in an isolated model, then you could also do that. So right now the default is running the container, spinning it up, running it with a public facing IP address. That's easier for my demos. But if this is like an internal application, then you could also move it to a private Azure Virtual Network. Next, you need to define the running port. Now, again, out of the container image definition, the container itself already knows that my application is running on port 80. That's what I define in the Docker file configuration settings parameter. But if you want, you could also expose other ports. So we're going to push the button. It's going to reach out to our Docker supported Docker standard container registry and pulling up the container and running it from there. So this process typically takes a couple of minutes. Now, I do like live demos, so I'm actually going to give it a little bit of time and waiting for it. So it's creating my Azure Container Instance resource. Which means that I should have a new resource group for ACI. It's not there yet. There we go. ACI resource group. And it's starting up my container instance. So the instance service is already there. And in the meantime, my container is also running. So again, as you can see, pretty fast and most probably a lot faster than running the same in a virtual machine environment. It gets a public IP address. And again, that's why it's out of my selection to provide it a public IP, which means if all goes fine, I'm connecting to my container, and that should give me a nice e-commerce interface. And just for my demo, I can select what kind of products I want to try and sell you. It's phone jar fashion. It's not that important. It's not even container related. Now, just to complete my scenario, so I'm running my web front end inside a container. It's a .NET Core example, but the content of my web shop is technically coming from a SQL database. So that's the other nice integration you have, that your container workloads can interact with all other parts in the platform. And what I'm using there is SQL Azure database that I deployed earlier. And within the database, that's where I'm going to store all my products. So pretty similar to your web config file or the app settings JSON file in your .NET application, where you point to a local running database, SQL, Oracle, MySQL, doesn't matter. I did the same in the source code. And when I built my container image, it's literally picking up the web config file. You could make it more complex and adding a Docker settings file into your Docker file compiler, and even defining that this time the container comes up and using a test and dev database. And once it moves to production, that we're going to use a production database. But again, think back about my rule, don't make it more complex than it should be. And that's my running application. So from here, it's a full-blown web app. I could order stuff, products, check my orders, and so on and so on. The other scenario is using Azure Web Apps and running container-based workloads inside Azure Web Apps. So if you're familiar with Azure Web Apps, no surprises there. It's our web server as a service in the Azure platform, where you typically publish source code for different development languages. And now you could also bring your container. The main difference between container instance and web app is that a lot of the core characteristics, feature capabilities of web apps in Azure are now also available for containers. So if you need auto-scaling, load balancing integration, like in front of your e-commerce example in my environment, if I want better high availability, I could deploy 2 container instances and from there moving to web apps. Or if you want better high availability, if you would check in the details on the SLA, the container instance SLA is lower than the out-of-the-box web app SLA. Other features, backup recovery, mixing private public registries would be supported, but that's the same in the instance. And then again, Docker Compose, allowing you to, instead of just running one single standalone container instance, you could move to a group of containers and running them as one single application stack. I see some questions coming in, but I got about 10 minutes left, so I would recommend or suggest to move on and finishing, and then we do have some time left for answering your questions. But thanks for firing off the questions, and I'll guarantee I'm going to answer them. So I'm going to close this one and showing you how easy it is to spin up a web app for containers. So a lot of it is almost identical to my previous demo, where we start with, again, some base Azure information. I'm going to use the same resource group, but it could be a different one. It needs a web app name. So this is the scale me up web app container, where this time I'm not going to publish application source code, but I'm going to publish a Docker container. I can choose Linux or Windows because now the interface itself has no idea about my backend container. And in the second step, I'm going to define what container I'm going to use, a single one or the grouped one with Docker Compose, and where can I find it. So this is 100% identical to my previous part, so this is going to be easy. Confirming all my settings, and it's deploying. Now this is going to take a bit longer because it first needs to create a web app service. After that, it's going to reach out to my container registry, copying the container image, and eventually running it. So it's still not taking super long, but at least a bit longer than just spinning up the container instance. So I'll keep this running, and that allows me to move on to the last part, and that's really running in a full optimized way. Because up till now, we have standalone instances. We have a couple of high availability load balancing features out of web app for containers, but it's not a full-blown orchestrator. What if you need auto-scaling? What if you need rolling updates when you got new versions of the backend coming out? What if you want to use more optimized, integrated networking, proxy, reverse proxy? Maybe your application needs like session affinity, or maybe you want more granular resource sizing, where one container can have certain characteristics totally different than any other container. So what you need technically is an orchestrator. So what you can use here is Azure Kubernetes Service. Again, think back about one of my previous slides. It's not the only option we have, but it's probably one of the most popular ones. Now, what's a Kubernetes service? So it's Kubernetes cluster. So under the hood, if you want, it's offered as a service, but technically it's relying on virtual machines, where Kubernetes runs in a master worker nodes topology. So what it means is there is one virtual machine that's running the Kubernetes software, the Kubernetes intelligence. That's what I call the master brain. And next to that, you have worker nodes, again, other virtual machines running the Kubernetes software, and that's where you're going to host your containers, like running the containerized workloads. And in Kubernetes terms, we talk about pods. And it's a full-blown end-to-end virtual machine infrastructure, but again, you're going to use it as a service. Since it's relying on Azure infrastructure, it means that you can integrate with Azure load balancers, you can integrate with Azure firewalls, you can integrate with Azure Virtual Network. But again, you don't have to worry about all that. Once you deploy your Kubernetes service object, it's going to deploy everything for you. And once your Kubernetes is live, you need to integrate with configuration files. So you could use Kubernetes YAML files. That's what I'll use. But if you want to move to a more even more orchestrated approach, then out of Kubernetes itself, they also have a concept called Helm charts, and that's like building a pre-configured package and publishing your containers, or moving to a full end-to-end CI/CD pipeline approach using Azure DevOps or Jenkins or any other similar DevOps supporting pipeline tool. And initially, AKS on Azure only supported Linux-based containers, where now in meantime they support Linux and Windows together. So what we're going to do is integrating with our container registry. That's what we have up here. That's our starting point. And if you want, you could integrate with the CI/CD pipeline, that whenever you have a new container available in source control, it's going to push it to Azure Container Registry. And from there, we're going to publish it, run our container images inside a Kubernetes cluster. Or another scenario is where you're going to use Azure DevOps using Azure Dev Spaces, managing your Kubernetes cluster and building up your DevOps pipeline from here. Or the third option is integrating with a Kubernetes built-in concept called Helm charts. But all this is running inside the same AKS cluster. So again, a lot of different options there. And since we talked about DevOps, you could have an isolation of responsibilities where the developer starts in Azure Dev Spaces or maybe source control. Next to that, you have the Azure Cloud admins who are responsible for hosting, deploying the registry, maybe integrating with Azure DevOps. And next to that, you have a AKS management tool. And for everything that's operational and monitoring, we're going to rely on Azure Monitor. Now, the management itself is based on two different standalone parts. So the first one is a Kubernetes YAML file. And what we define in there, as you can see in this little example, is my source image. So I'm using my PDT simple HCR and my simple commerce source image. I'm telling Kubernetes that if you pick up this container, it needs to run on port 80, because again, in the end, it's a web app. Could be 443, could be port 8080, so not that important. And once everything is up and running, we're going to use another command line tool called kube control for validating, or later on, and that's my closing demo, managing everything from within the Azure portal. So I need another 2 minutes. So perfect timing to walk you through that. Now, first of all, my web app for containers is successfully created. And if all goes fine, I connect to my web app, and there's my e-commerce example again, 100% the same to running my standalone environment. Way cool. So now we're going to deploy a Kubernetes cluster. Now I'm going to disappoint you maybe, but we're not actually going to deploy one, because again, there's quite a lot of complex infrastructure involved, and the deployment itself takes about 15 minutes. So I'm not going to bore you with waiting for the deployment. I already have one, but at least I'm going to walk you through the different parameters you can define during the initial deployment. So the same scenario for the baseline, the Azure subscription, a resource group could be an existing one, could be a new one. We need a name for the cluster. So scale me up, AKS would be an interesting one. And the Kubernetes version. Remember, like almost 45 minutes ago, where I talked about the Docker desktop and Kubernetes compatibility. So I'm going to use the same version. Next, we need to define the node pool. So remember that the node pool is in the back an Azure virtual machine running Linux and having a certain virtual machine sizing. The default is 3 virtual machine nodes, because obviously we want to take high availability serious, which means that if I'm losing one node, I still have 2 left for actually running my workloads. In the next step, it needs authentication. What we're going to do here is creating an Azure Active Directory security service principal that's going to allow the AKS object to interact with other parts in the platform. In the next step, we define networking, basic or more complex. We can define what kind of load balancer we want to use in front of our AKS environment. If we want to integrate with Azure Log Analytics for the monitoring, if, for example, we want to use Azure Container Registry or maybe another container registry. And from here, you push the button. Again, I'm walking you through this in the portal. You can do the same using CLI, PowerShell, Azure templates, or even Terraform, Pulumi as infrastructure as code examples. I already deployed everything here, and the outcome of this is a running Kubernetes environment. How do I know that it's running? Because we have the container integration out of the monitoring. What it's going to show me, similar to other Azure services, if you should be familiar with them, you can get a view on the cluster and you can see that it's running. There's some CPU movement, the different nodes, and I'm running some containers already. So they are consuming some memory, and you can also see how many nodes I'm running. Now for this demo, I only have one node because I don't really need the high availability for my demo environment. Within the AKS environment, I'm running built-in, so I don't need to do anything for it. It's out of the box, running controllers. So that's really the orchestration part of it. So we do have OMS agents, so standalone controller integration for actually building up the dashboard I'm using right now. I got DNS integrated. I got Kube proxy, that's an internal networking engine, and I'm running my simple containers. How does it know what containers I want to run? That's in my Kubernetes YAML file, or if you want in the Helm chart, or in your Azure DevOps pipeline. And showing you what I had in my screenshot in the PowerPoint is my Kubernetes YAML file. So it's a technical YAML definition file in which I defined the name for my container app. And again, we talk about pods in Kubernetes terminology, where I specify pick up this image. So you recognize my previous used container registry. And again, my simple commerce example, running the container on port 80 and expose it to the public internet behind the load balancer. Next, you would do kube control, so command line kube control, apply that Kubernetes YAML file, and it's going to spin up my little containers. Then we can validate from here, kube control get services. And that's providing me a list of the actual running applications. So I'm running the Kubernetes cluster itself. That one is only an internal IP. Thank you for the one who's leaving. And thanks for the nice feedback. And I got my Kubernetes Simple 3. I got a few other ones, but not that important. And it means that if I connect to my external IP, the 20.50 and so on, if all goes fine, I should have my e-commerce example again. And there we go, the exact same thing. So from here, I could connect to my database again and up and running. So with that, we're a few minutes over time, and it looks like some of you are leaving, but I promised you some Q&A. So I'm going to open up the question list and validating what questions we have. So the question, one of the first questions is how we can manage different configurations according to different environments like dev and test and production. So a couple of different options. You could create different container instances, like defining a dev and test instance production instance, or even inside your Docker file definition parameter file, you could also use variables to identify dev and prod. The same for WebApp for containers. So you could create multiple instances. You could integrate with Azure deployment slots, for example. Thanks for the nice feedback. And those were the questions. For the ones who are here, feel free to fire off a few more questions. I'll hang around for another couple of minutes. Unless you don't have any other questions, then I would like to thank you for being here. And based on the feedback in the chat box, which, by the way, thank you again. Apparently you liked it. I was super excited. Hope that you enjoyed it as much as I did. And I would say happy containerization into the Azure world. Hope to see you again in one of the other Scale Me Up expert talks here. There's another question coming in. Can I showcase the configuration part? Do you mean the configuration part in, okay, for the dev and prod? Can I show you? What I'll show you is the Docker file. That's actually one thing I didn't show you. No, you don't have to use Visual Studio for that, but that's where I'm hosting my e-commerce source code, and that's where I have my Docker file. It's a pretty big application, so that's why it takes a little bit of time. Come on, Visual Studio, you can do it. Cool. So this is my .NET example, and technically what it's doing is running a .NET build. So it starts from my source container image. So that's why I had the .NET Core ASP.NET and the SDK on my local machine. So that's the starting point. Next, it's going to copy all the different modules of my application. And eventually, I'm going to publish it and run it. Now, what you can do here is integrating with a Docker environment file. So it would be a separate configuration file in which you're going to specify the actual variables. Now, I'm not really using it in my examples here, but you could create a separate Docker environment variable file in which you point to the database to be used, in which you're going to point to the dev and test environment. So that would be one. Another approach you have is the namings of your Docker images, where, for example, that actually should give something else, but I'll do it in this way. So this is my simple commerce example, but from another demo. And you can add naming tags as well. So I'm using dev, which means it's a dev container. And then eventually, this is what I'm using in my CI/CD build. So that's CI built in my naming convention. And eventually, this could be your production one. And then in your Docker file, you could come up with, or in the Kubernetes YAML file even, you could come up with validations that if you try to host like the simple commerce web host dev tag in a production cluster, that it's not accepting it. So that would be one example. And then again, everything that is pointing at hosting it could be different environments, different Azure container instances. You could create a AKS for prod and AKS for dev and test. So that's how you could manage that. Cool. So it looks like most of you are gone and still very satisfied. So with that, I'm going to close down. Thank you so much for being here, and hope to see you again in one of the other Scale Me Up sessions. Have a nice evening and a nice rest of the day.